All right, in this video, we want to talk about graphing in the polar coordinate system. So this is going to be a little bit different than what we're used to seeing. So if you remember with the rectangular coordinate system, we're used to seeing your ordered pairs being x and y. Well, for the polar system, we're going to be talking about r theta. So it's a little bit different when it comes to plotting these points. It's not just finding the coordinate. You've got to pay attention to the radius, and you also have to pay attention to the angle. So if you look at the grid that we have right here, now this is not perfectly marked out, but it's going to be good enough to work with. You've got the key things marked. You've got pi over 6, this is pi over 4, pi over 3, and of course pi over 2. Right? So if I were to plot a point, let's say 3, comma pi over 4. We need to understand that we're first looking for our theta, which is pi over 4. So we're looking at this part right here, and we're going to use this radius of 3. So to plot the point, you find where pi over 4 is, and you mark out 3. So I'm going to make sure I do this correctly. 1, 2, and then 3. So this is going to be the ordered pair 3 pi over 4. Okay, let's take a look at this next example. Negative 9, 5 pi over 3. So it's a little bit different whenever you have a negative radius. So negative radius means you're first going to be pointing in the direction for your angle, in this case 5 pi over 3, which is down here, but you're not going to go 9 units this way. The negative 9 means that you are aiming in the 5/3 pi direction, but you're going to be going in the opposite direction. So just imagine that this guy is, if you can connect this all the way back over here, that's going to be in the 2 pi over 3 direction. So we're going to take this all the way out 9 units. So negative 9 units from the direction we should be facing. And here we have negative 9, 5 pi over 3. All right, and now let's look at this one. Negative 6, negative 7 pi over 6. So this one is a little bit messy, but keep in mind where things are. So negative 7 pi over 6, and of course, remember things about, remember coterminal angles? So that's the same thing as 5 pi over 6. I mean, you can start here at 0, and you work your way backwards to 5 pi over 6. So you'd be aiming in this direction. However, it says a radius of negative 6. So we got to go backwards here, and we have to go 6 units in the opposite direction. And so here you would have negative 6, negative 7 pi over 6. Now, as you can well imagine, there are multiple ways that we can get to these same points, because I just talked about coterminal angles, right? So this point right here in red, you could also say that this is negative 6, 5 pi over 6 for being coterminal. Or you could look at it, I mean, if I were to look at it right now and I had to plot that, I would say positive 6, and then I would say 11 pi over 6. So a lot of different ways that we have of rewriting this so that we can maybe have a stronger understanding of where these points are. So here is a general form for this. So if we have r theta, of course, because things are coterminal, we can say this is the same thing as saying r, getting ahead of myself, theta plus 2 pi. Yeah, you know what? Let me say 2 pi k, right? Because it's not just 2 pi, but any integer multiple of 2 pi. Or you could say this is negative r, theta plus pi plus 2 pi k. And again, this is with the understanding that k is an integer. So this part right here is just helping you be coterminal. And this plus pi, along with the negative, kind of flips you on the other side and adds pi so that things line up the right way. So for this guy right here, this negative 6, negative 7 pi over 6, If I were to change this to a positive, it's now facing in the other direction, which means a complete 180, which is where that plus pi comes in. And yeah. So just keep that in mind, and you're going to be pretty straight about this. Now, the next few videos that we're going to be looking at are converting between polar and rectangular coordinates and back and forth, both with the points and with equations. So the best piece of advice I can give you is to take your time, slow down, and watch your signs. Okay, you got to make sure you know how the conversions work. So I'm going to give you a few of the conversions things we've already seen before, and we're going to take those and apply them to all kinds of situations.